All right, so with this video, we are going to talk about significant figures in chemistry. I would like to, draw your attention to there's really two major numbers when it comes to significant figures, and we're going to have our non-zero integers and our zero integers. All right, so let's look at examples of non-zero integers first. So when I say non-zero integers, I'm talking about numbers 1 through 9. And those numbers are always going to be significant. So for example, I've got a couple examples right here. So the number 12 has two significant figures because 1 and 2 are both non-zero and they're both significant. About 13.82, that has 4 significant figures. They are all non-zero integers, so they are all significant. And lastly, 1.7839, that has 5 total significant figures because all of the numbers are non-zero integers, and non-zero integers are always going to be considered significant. So the trouble with significant figures, I wouldn't say the trouble, but the confusion maybe comes to when you have a 0. All right, so there's actually 3 different scenarios where you can see a 0. So I've got a number here, 0.2400. And that shows the 3 different scenarios you could come across. And we have what we're called leading zeros, we have captive zeros, and we have lagging zeros. So leading zeros are going to be any 0 that comes in front of the very first non-zero integer. Those are all going to be called leading zeros. Captive zeros are zeros that essentially are sandwiched in between 2 non-zero integers. And lagging zeros are zeros that come at the very end of the number after the last non-zero integer. So let's look at these examples one at a time. So let's look at leading zeros first. So leading zeros are actually never going to be significant because they're really just placeholders. So they don't count towards a digit that I am certain is there. It's just a placeholder. So some examples here would be maybe be 0.18. So that 0 is not significant. So 0.18 has a total of 2 significant figures coming from the 1 and the 8. What about 0002.14? Those 3 zeros are placeholders and they're really there for no good reason. So those are not significant zeros at all. This whole number, even though it has a total of 1, 2, 3, 4, 5, 6 numbers, has only 3 significant figures, which is the 2.14. And lastly, here's another example of some leading zeros that are never significant, 0.0732. So these 2 zeros are in front of the very first non-zero integers, therefore they are leading zeros and they are not significant. So 0.0732 has a total of only 3 significant figures coming from 7, 3, and 2. All right, so leading zeros are never significant. Let's look at captive zeros. So captive zeros, again, are zeros that are going to be sandwiched in between 2 non-zero integers. Captive zeros are always significant. So they are placeholders, but you are certain that those values do exist. So here's some examples. 1002. So I have 2 captive zeros, but they're sandwiched in between this 1 and this 2. So these are the 2 non-zero integers. So all 4 of those numbers are significant. How about 10.87003? In this case, I kind of have 2 groupings of captive zeros. I have this captive zero between the 1 and the 8, and I have these 2 captive zeros between the 7 and the 3. And again, captive zeros are always significant. So every single number in this number right here is significant. So 1, 2, 3, 4, 5, 6, 7. This number has 7 significant figures. Lastly, 280.0714. There's our 2 zeros and they're held captive in between these 2 non-zero integers. So all of these numbers are going to be significant. So I've got a total of 7 significant figures in that example right there. All right, so captive zeros are always going to be significant. Let's look at the last type of zero, which is the lagging zeros. And the lagging zeros, it just really depends. Sometimes they're significant and sometimes they're not. So here's where the confusion could come into place. So I'm going to kind of zoom in on my examples here, and we'll discuss each example. So again, lagging zeros are the zeros that come after the last non-zero integer. So look at these two examples here. I've got 10 and 10 point. And then down here, a third one, I've got 10.0. I should move that up, but here, let's look at these three examples. So I've got 10, 10 point, and 10.0. I've highlighted the lagging zeros in orange for these three examples. And I'll say right now, the number 10 without the decimal place, this lagging zero is not significant. So that would be a not significant. Let me make that red. That one is not significant because you are not certain, because 10 could be a number rounded. That could have actually been 8, but you rounded it up to 10, or it could have been 12 and you rounded it down to 10. So that is not a significant figure. So the number 10 only has one significant figure. The number 10 point, however, once you put that decimal place right there, now you're telling me you are absolutely certain that that is 10 exactly. It wasn't 11 rounded down. It's not 9 rounded up. It's 10 exactly. So the number 10 point actually is two significant figures. And I guess I can go back up here and I say this is one significant figure. What about our third example down here? What about our 10.0? 10.0, again, because we put that decimal place there, now that zero, both of these zeros matter. I know it is exactly 10.0. So this example has a total of 3 significant figures. All right, let's look at these two examples here. This is kind of playing off that the same kind of rule of, including that decimal. So I've got 38,000 and 38,000 point. The number 38,000, these lagging zeros are actually not significant. That number could be a rounded version of a longer number. So this number right here only has 2 significant figures, and those 2 significant figures are the 3 and the 8. Once you put that decimal place there, though, now you are telling me that you are absolutely certain that that number is 38,000 exactly. So that these 3 zeros do become significant. So this number has a total of 5 significant figures. What about lagging zeros that come after a decimal place? So for example, I've got my 2 examples down here at the bottom. 3.7850 and 0.2100. Zeros that come after, lagging zeros that come after a decimal place will always be significant because you are certain that this number is 3.7850 for sure. And you are certain that this is 0.2100 for sure. So how many significant figures do these have? Remember, all of the zeros that come after a decimal place are always significant. So we've got a total of 1, 2, 3, 4, 5 significant figures here. And here's a leading zero. That is not significant, right? We know leading zeros are not significant. Oh, it's not going to let me erase it. Let me just put a big red mark over that, right? Not significant. But we do have 1, 2, 3, 4 significant figures in that example. Okay, so to recap, when we're talking about significant figures, we kind of break it down into 2 things. We break it down into non-zero integers and 0. All non-zero integers, that's numbers 1 through 9, are always going to be counted as significant. It's only when we're talking about zeros do things get a little iffy. And there are 3 scenarios for zeros, right? The leading zeros are never significant. Captive zeros are always significant. And lagging zeros, it totally depends. And again, that's going to depend on whether or not you are in front of or after a decimal place and what else is around.